In this video we're going to look at comparing a sample proportion, which is p hat, to a population proportion, which is p. The equation that we're going to use here for the z-score, p hat minus p divided by the square root of pq over n. The margin of error equation we just learned in the last video for a confidence interval, and then you would take the sample proportion p hat plus or minus e to make your confidence interval, Ci. So this method we've used before, the confidence interval, we just learned that, and we know about z-scores and areas. So again, this is just applying what we've learned to a new type of problem. Requirements. This is something that you should check before you do any problem, just to make sure that it's the right kind of data that this type of equation will work for. So the first requirement is you have to have a simple random sample, and I'm going to abbreviate that SRS later. We have to be working with proportions, which is x out of n, and we need to check to make sure that n times p is greater than 5 and n times q is greater than 5, and remember q is 1 minus p. So 3 things to check before you do any problem. We will have requirements for all the different kinds of problems we do in this unit. They'll be a little bit different for each one. Okay. Next thing, we have 3 different methods we can use to solve problems. We have the p-value method, where we compare the p-value to alpha. We have the critical value, where we compare a test statistic to a critical value of z. And we have a confidence interval. And the way that we can use confidence intervals to solve these problems is if the confidence interval that you calculate does not include the population proportion from the null hypothesis, you reject the null hypothesis. So I'm going to do an example. The first part of the problem applies to all 3 methods. You should do the first part of the problem for any method you choose. And then after that, on the next page, we'll look at each method individually. They're all going to lead to the same conclusion, but we'll look at the process for each one. So here's our example. So we're reading an article, and it claims that 85% of Americans, which would be 0.85, think that texting while driving should be illegal. So you perform a survey, and of the 1,267 responses, that's the total number of people in your survey, that's going to be n. 1,039, that's going to be x, how many say a certain thing, say it should be illegal. We want to know, is our sample proportion, the 1,039 out of 1,267, is that different from the claimed proportion of 0.85? And they give us a value of alpha to use. So the requirements: has to be a simple random sample, has to be proportions, and we need to check if NP is greater than 5 and if NQ is greater than 5. So simple random sample. All it says is you perform a survey. It doesn't say how you performed the survey, but let's assume that you know how to take a survey and that you did it correctly. So we'll say it doesn't say in the problem that you did it correctly, but we're going to assume that you did. Okay, so I'll check that one. This type of problem requires that we're working with proportions, some number out of a total number, and that's true. We have 1,039 out of 1,267. Okay, next thing to check, n times p is greater than 5. Our n is 1,267, so you can be pretty sure that n times p is going to be greater than 5, but the p that we'll use is the population proportion claim, 0.85. And that number is going to be close to 1,000, so we're good there. N times Q, Q is 1 minus P, so 0.15, and that's a little over 10%, so you're still looking at numbers over 100, which is well over 5, so yes, both of those check out. So all of our requirements are okay. and we can keep going. So number 2, summarize the data. I kind of did that as we read through the problem. We have population proportion of 0.85. We have X is 1039, N is 1267. We could calculate P hat. And when you calculate that, we get 0.82. We could calculate Q hat just in case we need it later. And that should be it. We can make a note to ourselves that alpha is 0.01. And that's everything from the problem. Okay, so now it's all just summarized in one place. Right, the hypotheses. We have a null hypothesis, where P is equal to a claimed value. The claimed value in this problem is 0.85. The alternative hypothesis, key word in the problem is the word different. It doesn't say less than or greater than, it just says different. So the only thing we're going to change from our null hypothesis to our alternative hypothesis is the sign. Okay. The symbol stays the same, this P. The number stays the same, the 0.85. All you're changing is the sign, and we're going to use not equals because it says different. And now we get to where we can choose one of 3 methods to solve the problem. I'm going to show you all 3 so you have an example of all 3. And then in most problems we'll use the first method, which is the p-value method. But if it ever says to use a different method, you'll know how to do that as well. So the p-value method, in order to get a p-value we need a z-score. So we're going to calculate z. And our sample proportion was 0.82. Our population proportion claim was 0.85. That's the number we're using down here is the population proportion claim, 0.85. And Q is 1 minus P, so that's going to be 0.15. And we divide by N, which was 1267. So up here we'd get negative 0.03. And on the bottom, if you calculate all that out, you'd get right about 0.01. That's rounded a little bit, but the z-score, when you divide those, you should get right around negative 3. Okay. So from a z-score, we're going to get the p-value, which is the area. And we have to keep in mind, I'm just going to put up here our hypotheses. So remember that the alternative hypothesis was not equal to, so we need to do a two-tailed test, which means whatever p-value we get for negative 3, we have to multiply it by 2 to get the other side. So minus 3 is out here. The p-value is going to be this little tail. The mirror image, we'd have z of 3 over here and this little tail. And we're going to add those two tails together to get the p-value. So the p-value for the negative 3 would be the area to the left. So from minus 99 up to minus 3, the z distribution has a mean of 0 and a standard deviation of 1. And that would give us 0.0026. So this little area right here is 0.0026. Has to be a mirror image, so this area up here will also be 0.0026. So we can just multiply by 2. Oh, sorry. I got ahead of myself here. This will actually be 0.0013. These are each 0.0013. The total p-value, 0.0013 times 2, 0.0026. Okay, sorry about that. So that's our p-value. Now we're going to take our p-value and the alpha that they gave us in the problem was 0.01. And you can see that our p-value is smaller than alpha, and when the p-value is less than alpha, we reject the null hypothesis. So we can say that we have sufficient evidence to reject the claim that the proportion of people who think texting while driving should be illegal is 0.85. Or you could write it some other way. The proportion of people who think texting while driving should be illegal is not the claimed value Since we reject the null hypothesis, you can say that the value is not the claimed value from the null hypothesis. So that's another way to write it other than what your book gives you as examples. Okay. So let's find out how to do this on the calculator. One proportion z-test. Okay. Again, we'll get the same result. Under the stat menu, over to tests, and we're doing a one proportion z-test, and that is number 5. So the claimed proportion from the null hypothesis is what goes in for p0, and that's 0.85. X was 1039, N was 1267. The alternative hypothesis was different, so we're going to use not equal to, and then we want to calculate. And here's our result. Z equals negative 2.99 if you round it. And the p-value, this p right here stands for p-value, that is 0.0028. So not too much different than what we calculated by hand. We got negative 3 for a z-score. The calculator gave us negative 2.99. We got 0.0026 for a p-value. Calculator gives us 0.0028. Okay. So again, here you compare that to alpha. It's less than alpha. Reject the null hypothesis. Okay. So again, the equation, figuring it out with the z-score, and then plugging that in to get an area, or just plug the whole thing into the one proportion z-test function, and you'll get the p-value that way. That'll be the most common way we use to solve these problems, but again, let's look at the other two just in case you need them. Okay. We have the critical value method and the confidence interval method. In a critical value method, we want to compare some value of z, and I'm going to say z alpha over 2 because the null hypothesis was not equal, so we need the two-tailed z-score. And we're going to compare that to z for our test. And we just calculated that up above, and we got negative 3.00. So we just need this z for alpha over 2, and alpha was 0.01. So alpha over 2 is 0.005. And then we can just grab our table and find the z-score that we need. So we need, alpha is 0.01, so that's the third row down. Alpha over 2, you can see 0.005. And the critical z, the alpha that we need, is 2.575. So now we compare. Now, when you have a negative z-score, you want to take the absolute value. See, and we're only interested in the actual distance, not the whether it's negative or positive. So let's just use 3. So our test z-score is bigger than the critical value of z. It's further away from the population proportion in the middle. It's further away from 0, if you will. So when your test z is bigger than the critical z, you reject the null hypothesis. Now I'm not going to write the conclusion again, but it's the same as what I wrote earlier. So see conclusion above. Third one, confidence interval. Let's do a confidence interval in the calculator again. So it's a 1 proportion z interval. And the numbers that you'd need to put in are x, n, and the confidence level. They gave us alpha of 0.01. If you need a confidence level, they have to add up to 1. So if alpha is 0.01, the confidence level we're going to use is 0.99. So let's plug those into calculator. So in the stat menu tests, it's a 1 proportion z interval. And there it is. The number's already in here, so 1039 for x, 1267 for n, confidence level of 99 or 0.99, and calculate. And there is our confidence interval, 0.7923 to 0.8479, rounding a little bit. So the way that we evaluate confidence intervals to find out if we should reject or fail to reject the null hypothesis is if the confidence interval contains the claimed value or claimed proportion or not. So the claimed proportion was 0.85, and that is outside this confidence interval. Which leads you to reject the null hypothesis. If 0.85 isn't in the confidence interval here, that means that you shouldn't think that that value is correct or true. So we're going to reject the null hypothesis that the proportion is 0.85. And again, since these are all the same, it's the same conclusion. The proportion of people who think texting while driving should be illegal is not 0.85. So again, those are the 3 methods. Typically we'll use the first one, the p-value method, but again, sometimes you'll be asked to do a different one, and those are your examples to use to figure those out.